Hi there. We are going to talk about, in this video, solving logarithmic equations. All right, so let's go ahead and take a look at some examples here. Here we are. Here's our first equation. We want to solve for x. All right, so what is the x that would go there that would make this make sense? Well, remember what this means. Log base 3 of x is the exponent on 3 that gives x. But we're told that the log base 3 of x is 2. So that means 2 is the exponent on 3 that gives x. Write that down. 2 is the exponent on 3 that gives x. Well, there you go. I think I see what x is, right? X equals 9. Done. Okay, let's try another one like that. Log base 2 of x equals -1. Okay, go ahead and try this one. Write that one down, see if you can solve it. I'll pause the video. 3, 2, 1. Okay, welcome back. Remember, log base 2 of x is the exponent on 2 that gives x. But we're told that log base 2 of x is -1. So that means -1 is the exponent on 2 that gives x. -1 is the exponent on 2 that gives x. What's 2 to the -1? It's 1/2, of course. So there's our answer. All right, let's try another one. Let's try putting the variable. Sorry, let's try this. Let's try natural log. Natural log of x equals 8. Okay. Well, remember what natural log is. It's log base e. So this is saying that 8 is the exponent on e that gives x. 8 is the exponent on e that gives x. So in other words, e to the 8 equals x. Well, there's my answer. X equals e to the 8. Done. Okay. What if we do this one? Log base b of 16 equals 4. And I'm solving for b. I want to know what b is. Okay, so b is the base, right? So remember what this means. 4 is the exponent on b that gives 16. 4 is the exponent on b that gives 16. So I think I could probably see what b is. If you wanted to solve this, you could write b equals plus or minus the 4th root of 16, which is plus or minus 2. But remember, b can't be negative. B is always a positive number in this case. So b is actually equal to 2, right? Remember that b is always a positive number when we're doing logarithms. The base is always positive. Okay. What's coming next? Let's try this one. Log base x of 32 equals 2. See if you can write down the equivalent exponential equation for this one. Go ahead, pause the video. 3, 2, 1. All right. Well, let's see. Remember that this is the exponent on x that gives this, right? So 2 is the exponent on the base, which in this case is x, that gives 32. So x squared equals 32. Well, that means that x equals plus or minus the square root of 32. I can simplify this, though. That's plus or minus the square root of 16 times 2, which is plus or minus the square root of 16 times the square root of 2. And the square root of 16 is 4, of course. So this is plus or minus 4 root 2. But again, remember, b has to be, well, in this case, the base is x. So remember, x has to be greater than 0. So we take the positive answer. X equals 4 root 2. Okay, let's try a couple more. Let's try log base 2 of 3x minus 5 equals 4. Okay. Well, remember that this is the exponent, so 4 is the exponent on 2 that gives this. Just going back to how we define logarithms. So that's 16, 2 to the 4th is 16. Right, so I'll just solve this. Let's go ahead and pause the video, solve this, and we'll meet together. 3, 2, 1. All right, yep, we add 5 to both sides. Divide both sides by 3. And we see that x equals 7. All right, let's do one more. Here we are. Let's do natural log of e to the 3x equals 6. Okay, so 6 is the exponent on the base. The base here is e. So 6 is the exponent on the base that equals this, e to the 3x. How do we solve this one? Well, we use the one-to-one property of exponential functions, right? If you have two functions, exponential functions with the same base, and they're equal, that means their exponents must be equal. Watch one of my previous videos about the one-to-one property of exponential functions to see more on that. Right, so then we divide by 3. So there's our answer, x equals 2. Okay, so a variety of different equations to solve there. And hope you found that useful.